China has completed the final test of its highly classified hypersonic air-to-air missile, marking a significant advancement in its military capabilities. This announcement was made public on January 19, 2025. The missile is reportedly designed to engage high-value targets, including advanced stealth aircraft such as the US B-21 Raider bomber. China's hypersonic air-to-air missiles are built to target US stealth bombers, which could revolutionize air combat and shift the balance of power in the Indo-Pacific region. These advanced weapons highlight a new era in military technology and strategy. A Chinese J-10C fighter jet was recently spotted carrying the PL-17, an active radar-guided beyond visual range air-to-air missile, a sight that has raised eyebrows among military analysts. This integration could signal Beijing's exploration into new tactical approaches, potentially extending the J-10C's role in aerial engagements far beyond its usual combat radius. If this adaptation proves successful, it could significantly enhance the fighter's capability to engage targets at distances previously unattainable, thereby increasing its strategic value. The China Airborne Missile Academy in Luoyang, Honan Province, conducted the development and testing. Scientists working on China's Secretive hypersonic air-to-air missile revealed that the weapon underwent intense heat resistance tests to meet the strict requirements of the People's Liberation Army. This process ensures the missile can withstand prolonged exposure to temperatures exceeding 1,200 degrees Celsius, equivalent to flying at Mach 9 for an extended period. The wind tunnel, primarily used for challenging space missions, operates continuously for an hour or more, though its enormous power consumption makes it costly. Hypersonic air-to-air missiles can travel at speeds over Mach 5, creating new challenges and opportunities in modern air combat. Unlike traditional missiles with ranges of a few hundred kilometers, these advanced weapons can strike targets over 1,000 kilometers away. This extended range and incredible speed allow them to reach targets much faster than subsonic missiles. Their rapid trajectory makes them harder to intercept, leaving enemies with minimal time to react. Unlike conventional missiles, which require complex guidance and longer engagement times, hypersonic missiles significantly reduce the time from launch to impact, making them a game-changing threat for modern air forces. The development of hypersonic systems is both a technological and economic challenge. These advanced weapons require complex engineering and come with high costs, such as operating sophisticated wind tunnels for testing. Currently, only a few nations, including China, the US and Russia, are making significant investments in this cutting-edge technology. The Chinese hypersonic air-to-air missile marks a pivotal moment in the evolution of modern warfare, setting a new standard for the speed, range, and lethality of air-launched weapons. A Chinese J-10C fighter jet was recently spotted carrying the PL-17, an active radar-guided beyond visual range air-to-air missile, a sight that has raised eyebrows among military analysts. The PL-17, known for its exceptional range and advanced radar guidance, is typically mounted on larger aircraft like the J-20, China's fifth-generation stealth fighter designed for long-range missions with a capacity for heavier munitions. However, the J-10C, a single-engine multi-role fighter primarily meant for shorter to medium-range operations, has a more limited payload capacity, making the pairing with the PL-17 somewhat unexpected. Traditionally, the J-10C serves in roles focused on air superiority and ground attack, not as a carrier for the longest-range missiles in China's inventory. This integration could signal Beijing's exploration into new tactical approaches, potentially extending the J-10C's role in aerial engagements far beyond its usual combat radius. If this adaptation proves successful, it could significantly enhance the fighter's capability to engage targets at distances previously unattainable, thereby increasing its strategic value. The technical challenges are apparent. The PL-17 requires sophisticated electronics and radar systems for long-range targeting, which the J-10C's modern ESA radar might not fully support to the extent needed for optimal performance. Successfully harnessing the PL-17 with the J-10C would be a notable technological leap, demonstrating the aircraft's capability to outperform expectations. Moreover, showcasing the J-10C with the PL-17 could be a strategic move by China to display its prowess in integrating advanced weaponry across diverse platforms, even those not originally intended for such roles. This move not only boosts the J-10C's combat profile but also sends a clear message to regional neighbors and powers like India, Japan, and the US about the evolving capabilities and flexibility of China's Air Force. In a hypothetical conflict scenario with Taiwan and the US, this combination could redefine air combat roles. The J-10C, equipped with PL-17s, could act as a long-range strike fighter, engaging enemy aircraft from beyond visual range, potentially before they could respond. This capability would be pivotal in the initial phase of the conflict, where securing air superiority could dictate the pace and outcome of subsequent engagements. Furthermore, the J-10C could block aerial routes, defend Allied forces, or even spearhead initial strikes against strategic targets, disrupting enemy command structures and infrastructure before they can react. The fighter could also play a role in electronic warfare, jamming radar and communication networks, thus hampering adversary coordination and operational effectiveness. In combined operations, the J-10C's new role could provide versatile support to naval and ground forces, offering a broad spectrum of attack options across different domains of warfare. This adaptability would not only enhance China's military effectiveness but also complicate defense strategies for potential adversaries. In essence, the combination of the J-10C and PL-17 could significantly alter the strategic landscape in East Asia, providing China with a distinct advantage in air combat scenarios, particularly in the critical early stages of any potential conflict. The PL-17, an advanced air-to-air missile from China, presents an array of significant technical challenges that its developers must overcome. This missile, which has been spotted on various Chinese fighter jets, is designed to operate at speeds that push the boundaries of what's currently possible in missile technology, potentially reaching or even surpassing Mach 6. Such high-speed performance requires a sophisticated aerodynamic design to maintain stability and maneuverability under extreme conditions. The propulsion system of the PL-17 is another area where innovation is critical. It must balance high thrust with fuel efficiency to achieve the missile's impressive range, rumored to exceed 300 kilometers. Advanced technologies like dual-mode or scramjet engines might be in play here, which adds layers of complexity to both design and implementation. Guidance and control systems are at the heart of the PL-17's capabilities. With an active radar seeker, the missile must be able to lock onto and track targets at long distances, even amidst electronic warfare attempts to jam or deceive it. This involves integrating state-of-the-art sensors with the missile's control algorithms, ensuring it can adapt to various countermeasures in real time. Additionally, the missile likely employs a data link for mid-course guidance, which must be robust against interception or jamming.